Alright, in this video we're going to be going through the determinant of matrices. And we'll be going through the specific examples of a 2x2 and a 3x3 matrix. So for the 2x2 one, it is fairly simplistic. The formula of it would just be AD minus BC. So let's say that this matrix is 7, 0, 3, 4. Then the determinant would be 7 times 4 minus 3 times 0, which would be 28. But on a 3x3, it'll be a lot more complicated because in this case, this formula can't be applied there. We're going to have a different formula. So let's say it'll just be I, J, K, A, B, C, D, E, F. So in this case, the formula for the determinant would be B, C, E, F times I minus A, C, D, F times J, and then plus A, B, D, E times K. So we can notice here is for this, you're multiplying the two columns of matrices that aren't part of the value out here. So for the I value, or for the one that's for the matrix that is being multiplied by I, you get the values in the column under J and K, which is B, C, E, F, and in the matrix that's being multiplied by J, you get the values that are in the columns under I and K, which is A, C, D, and F. And for the matrix that's being multiplied by K, you multiply it by the matrix values that are in the column of I and J. So pretend that there's like a line here. The ones in the first row are the ones that are being multiplied on the outside. The ones in the next two rows are inside the matrix. And this is also something in I think in three-dimensional vectors when you're trying to find a cross product. And yeah, so do an example with the 3x3 matrix. Alright, I erased the 2x2 section to make room so we could have a matrix. What we could do is we could pretend there's an imaginary line here, and using this formula we could find the determinant. So let's also write I, J, K here just to get the gist of what's going on. So for the matrix that has I in it, this would be the values in columns J and K, which is 0, 4, 5, and 1. Now instead of putting I in there, we're going to put the value that is being substituted for I, which is 1. And it'll be minus the matrix times the value corresponding to J, which is 5. And inside the matrix, it's going to be the two columns that are not that's not the J column. So that'll be these two, and it'll be 2, 4, 1, and 1. And this will be plus, I think I could put enough room here. It'll be plus the value that's another matrix that's corresponding to the value of K, which would be 3. And we would input in the matrix the values that are in the columns that are not corresponding to K, which would be 0, 2, 1, and 5. And now we could use the example. We can now use a formula for the 2x2 determinant because there's 2x2 matrices here. And just for reference, it'll be AD minus BC. So, and this will be what the 2x2 matrix will look like. And when we simplify this, it'll be 0, 1, and 4 times 5, all multiplied by 1. And this would be 2 times 1 minus 4 times 1, all multiplied by 5, plus 2 times 5 minus 0 times 1, all multiplied by 3. And when we simplify this, it'll be 0 minus 20 plus 1 minus 2 times 2 minus 4 times 5 plus 10 minus 0 times 3. And now we could simplify this to be negative 20 minus negative 2 times 5 plus 10 times 3. And this would be negative 20 plus 10 plus 30, which gives us the value of 20 as our determinant.